So our first example, we're actually going to work on representing this same function, but in our introduction we talked about representing this function centered at x equals 0, right? And so we know how to do that, but now we want to center it at x equals -1. All right, so if we're going to use a power series centered at x equals -1, we know that we're going to have powers of x plus 1 to the n. All right, in our final series, we're going to have powers of x plus 1. All right, so we have to get this thing, we have to rewrite this function so that we can get an x plus 1 here. All right, so here's how we're going to do that. I take the 1 minus x in the denominator, and I'm going to make it 1 minus, here's the x plus 1 that I want. Now I added a 1, all right, in here, but since it's multiplied by this -1, I'm really, by adding this 1 in the parentheses, I'm really subtracting 1 from the overall value of the denominator. So to maintain this equality, I have to add 1 to the denominator. And now that 1 and this 1 give me a 2. So I have 2 minus x plus 1 in parentheses. All right. Keep in mind the form that we're looking for is this. All right. Notice that a could be anything, r can be anything, but we need a 1 here. So right now I have a 2. So in order to get that to be a 1, I have to divide by 2. Therefore, I have to divide everything by 2, numerator and denominator. All right. So now I have 1/2 over 1 minus the quantity x plus 1 divided by 2. So I've effectively got it in this form. So here a is 1/2 and r is x plus 1 over 2. So when I write that as a geometric series, my a is here, my x plus 1 over 2 is raised to the n power, and I'm writing the summation from n equals 0 to infinity. Right? For this series to converge to the function that I want it to converge to, 1 over 1 minus x, for this series to converge, I have to ensure that x plus 1 over 2 is less than 1, or more precisely, the absolute value of x plus 1 over 2 is less than 1. All right, so that means that the absolute value of x plus 1 has to be less than 2, and I'm centering it around x equals -1. So my radius of convergence here is 2, and therefore the interval of convergence is from -3 to 1. All right. Note here that I know that I'm going to diverge at x equals -3 and x equals 1 because this is a geometric series. So my my r has to be less than 2, has to be less than some value, in this case 2, for my series to converge. All right, let's take a look at another example. So here I want f of x equals 4 over x plus 2. I want to represent that as a power series centered at x. So here I just need powers of x. All right, so I want to make it look like a over 1 minus r. So I can first just rearrange this so it's 4 over 2 plus x. And I know I need a 1 here. So I divide everything by 2. Divide the numerator and denominator by 2. Now I have 1 plus x over 2, but I want 1 minus r. So 1 minus -x over 2. And then I have it in the form that I want. A is 2 and r is -x over 2. And so I can write that series this way. Here's my a, here's my r raised to the n power. All right. Now this is only going to converge if that r, the absolute value of r, is less than 1. So I need the absolute value of -x over 2 to be less than 1. So my radius of convergence is 2. All right. So I have x over 2 is less than 1. So the absolute value of x is less than 2. So my radius of convergence is 2. I'm centered at 0 up here. So my interval of convergence is from -2 to 2.